Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Okay. In this moment, I would like to continue my explanation about the chapter 2 of Diode applications. Okay, after we learn about the series configuration, parallel configuration, and the logic gate using a diode, in this subchapter we will discuss about the rectifications. Okay, and rectification is very popular in our daily life. Is like cell phone charger, laptop charger, all of this device using the phenomena or the characteristic of rectification, because the input voltage is AC, okay, AC, and then convert to DC, and then we can use it as our daily life. Okay, so there are two commonly there are two ways to to have a rectification or to perform a rectification from AC to DC. The first one is half wave rectification. So half wave rectification is basically very simple circuit. We only use a single diode here, and then we have a load here or R. If we have input voltage of AC like this one, so this is the AC, this is the positive cycle and negative cycle, and then we construct our device like this one. So we can analyze how the circuit can rectify the AC signal. Okay, the first one, when the input signal is a positive cycle, a half of positive cycle, like I make up like this one. So this is the half positive cycle. So the diode is connected to the positive because the input is positive here. It's connected to positive. So I can put this is the positive and this is the negative, and then the terminal negative is connected to terminal negative also. So because of the diode is forward bias, so it's like a short here. So in the output we can see that there is a current flow here. So the phase output is similar to phase input. So if we plot a waveform in the output, so we can get like this one. Okay, so in this case we also can analyze by, because there is a forward bias, so there is a current here, so the VO is I dot R, and then we can get the similar waveform with the input voltage. And another in another, after we decide the positive cycle, we analyze when it's from 0 to period per 2, or the negative cycle like this one. This is the negative cycle here. This is the negative cycle. So in negative cycle, the diode will be reverse bias. The negative terminal connect to the positive diode. This is the positive diode here, and then the positive signal connect to the negative diode. So the diode is reverse bias. So if reverse bias, the diode will be off, there is no current, so the output voltage is also zero because no current flowing in the output voltage. So in the negative cycle, there is no output voltage. So we can get that only in positive cycle, there is we can find the output voltage. Okay, so from this input voltage, we can get the output voltage like this one. Okay, and then the average of the output voltage is this value 0.318 Vm. Vm is the maximum voltage. Okay, so if we use the diode here, so we have to decrease Vm here, because there are a threshold before the diode can conduct a circuit. So we put the VA minus VK here. So it's mean that the efficiency of rectification of the half cycle is only 31.8%. So it's a little bit low. And then actually this is not the ideal DC voltage. So we have actually we can add like capacitor here. So we can make the output voltage is stable like this one. So if we put a capacitor, a little bit large capacitor, so this is the charge and this charge and this charge like this one. So we can get the stable DC voltage. Okay, so this is the example. If we connect its reverse bias like this one, so what's happened? In positive cycle, there is no current because the diode is reverse bias, and the negative cycle here, this is the positive or forward bias. So this configuration can conduct the current in the negative cycle. So we can get the output waveform like this one. And then because this is using this silicon, so we have to put this equation VA minus 0.7, so we can get that VDC is minus 6.14 volt. Not minus because the DC is negative, only conduct in negative cycle. Okay, so this is the peak inverse voltage, or PIF or PRF, peak reverse voltage, is a rating of the diode is of a primary importance in the design of rectification system. So we have to, if we use the diode, we have to looking for the diode who can conduct the or the breakdown voltage of the diode is more than Vm. Vm is maximum voltage. So if the diode is lower, the diode PIF rating is lower than the VM, so the diode will break down. So we have to carefully select the diode if we use as a rectifications here. Okay, so after we discuss about the half wave rectification, we use the full wave rectification here. In full wave, we use the 4 diode here. Okay, this is the first positive cycle. Okay, we will look for a positive cycle like this one. So this is the positive and this is the negative. So the forward bias, this is the positive or negative, positive and negative. Okay, negative, positive, like this one. So this is this will be forward bias. So this is the on, and this is also on, and this is the off because negative connect to the positive diode and positive to negative diode. So this is off and this is also off. So in positive half cycle, the current will go like this one. Okay, so this is the current flow in positive cycle. Okay, so we can draw the voltage, the output voltage in the resistor by using the I dot R. So we can get that output voltage is like this one, is similar to input voltage. Okay, and in negative cycle, we can see that actually this is a diode here like this. I draw a diode like this one. Okay. Okay, that's like this one. So in negative cycle like this one, so we can represent that this is the positive and this is the negative because of the negative cycle. So this is the negative, this is the positive, this is the negative, positive, positive, negative, positive, negative. Okay, so we can see that this is the negative terminal of voltage connect to positive diode. So this is the off, and this is the negative connect to negative, positive to positive. So this is the on, this is the on, and then this is the positive connect to the positive, negative connect to negative. This is the on also, and this is negative connect to positive diode here. So this is the off. So the current flow in the negative cycle is like this one. Okay, it's connect to diode like this one. So this is the current flow. So we can see that the current flow in the resistor in similar way. I mean that from here, from right hand here to the left side. In this also from right to the negative. So the 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 current flow in the resistor in the similar magnitude. So we can construct the output waveform by using this one. This is the positive. So for the full wave rectifier, by using this full wave rectifier from the AC, we can get that the DC rectification like this one. So this is the on and then on. In the positive cycle and the negative cycle, there is a magnitude of the output waveform. And then we can see that the average voltage, the DC voltage is increased from around 21% for half rectifier is increased to 63% in full wave rectification. Okay, so the efficiency is increased by using the full wave rectification. And don't forget, we have to put a Kenny voltage here if we use the diode silicon. So the VO max is Vm minus 2 Vk. Why 2 Vk? Because in current flow in two diodes, this is the first one and the second one. And also from the half negative cycle, we here and here. So always through a 2 diode. So we have two minus 2 Vk. So this is the final. VDC is 0.636, Vm minus 2 Vk. And PIF also, we have to select the best diode for the full wave rectification. And another configuration, if we can use a center tap transformer here. Okay, in center tap transformer, we use a transformer. This is the input voltage. And this is the diode. We use only two diodes, D1 and D2. And this is the transformer here. Okay, so in the positive cycle, like this one, so this is the positive cycle. Here also positive in center tap trafo, negative, positive and negative. So we have the diode here and also diode here. From this one, this is the diode connected like this one. Okay, so the positive connect to positive terminal, negative to negative. So the current flow here. But here, okay, this is the diode here. Negative connect to positive, positive connect to negative. So the diode here is off. So only the current only flow in the upper side like this one. So the output voltage will be like this one. We throw of output voltage in the R in the resistor like this one. Okay, in negative cycle, so this is the negative, positive, negative, positive. Okay, so the diode like this one, similar. Okay, so this is negative connect to positive diode and positive connect to negative. So this is the off, and here the positive connect to the positive, negative connect to negative. So this is on. So the current will flow like this one. And in the resistor, the current flow in the same direction here, the right side to left side. So in the negative cycle, we can draw the voltage like this one. It's similar to the full wave rectification. So we have the output waveform is similar to full wave rectification. Okay, and in the PIF, peak inverse voltage is increase because we use CT transformer. So PAF is phase secondary plus VR. So we have Vm plus Vm here. This is the Vm plus and negative Vm. So we have the PAF equal to 2 Vm. Okay, so this is for example. You can see by yourself, yeah, for this circuit, how to construct output voltage waveform by this circuit. Okay, and then this is the diode application, another diode application. The first is clippers. Okay, so clippers is like a clip away. If we have like this one, this is the input voltage. So we want to clip the negative cycle. So we can use this one. and then we clip the negative cycle like this one and also this one. Okay, and then we can put a battery here before the diode, so we can clip more because we have the threshold voltage, transition voltage here. So we have to put another VD here. Okay. Okay, so this is also the clip. We can clip, and this is if we use the parallel voltage. If a series voltage, we clip the negative cycle. In parallel configuration like this one, we clip the positive cycle like this one. Okay, you can you can see by yourself how a clip network is work in here. Okay, so this is the clippers, the summary. This is the negative, yeah. This is the positive clippers, and this is the negative clippers. Okay, and then another is clampers. So like this one, from input voltage active one, we can increase the output voltage in the negative cycle by using this network. So I didn't want to explain more in the clipper and clampers. I just want to tell you what is the clippers and clampers, and please in the assignment for the class you have to learn more detail about this clipper and clampers. Okay, so basically the diode can be used as clippers and also as clampers. Okay. Okay, another application is Zener diode, and okay, this is the Zener diode and voltage multiplier. Okay, we can make a voltage doubler here. Okay, so in a voltage tripler or quadrupler is mean that if we have like voltage doubler, it means that we have the 200, we have the 220 volt here. We can make a double like 440 volt here. So this is the voltage doubler. A triple is mean that we make a triple voltage. We can see that this is the from 1 VM maximum, and output is 2 VM here. And then if we have voltage tripler, so from VM we have a tripler here, 3 VM, this is the doubler, and also quadrupler here, 4 VM. Okay, so and then another is diode application and practical application. You will learn in the lab. Okay, I think this is the second part of the diode applications. Thank you for your attention. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.